Welcome to Scispectrum Lab Essentials, your source for equipment, instrument, and consumables.
Hey everyone. Today we're going to pull back the curtain on a really cool piece of tech. It's a lab instrument that's basically designed to find the unfindable, to see things that are literally invisible. It gives scientists an incredible way to measure what's hiding right there in plain sight.
So, let's start with the big question, right? How in the world do you measure something that's so diluted it doesn't even change the color of the water it's in? This is a huge deal in so many fields. From medicine to environmental science, where just the tiniest trace of something can make all the difference.
Well, the answer is a technique that is just worlds more powerful than the standard methods. You see, normal color-based methods, they work, sure, but this other method we're diving into, fluorometry, it can be anywhere from 10 to 1,000 times more sensitive. To put that in perspective, that's kind of like the difference between spotting a big, bright streetlight versus trying to find a single firefly from a mile away.
So here's our game plan for how we're going to break this all down. We'll start with the basic science of how things glow. Then, we're going to peek inside the machine itself, see what makes it so powerful, and finally, we'll see how it all affects our actual lives.
Okay, first things first. We have to get a handle on the core science that makes all of this possible, and it's a pretty amazing phenomenon called fluorescence.
So, in the simplest terms, fluorescence is just what happens when certain molecules get zapped with light. They absorb that energy, and then almost instantly, they shoot it right back out as their own little flash of light. It's not a reflection, it's a real, genuine glow coming from the molecule itself.
Here's the play-by-play. Think of a specific color, or wavelength, of light as a key. When that exact key hits the right molecule, it gets all energized. It absorbs that light, and for just a split second, it's in this excited state. Then, to get back to normal, it has to release that extra energy. And it does that by spitting out its own little burst of light.
But here's the magic trick. This is the secret to the entire thing. The light that the molecule shoots out is different from the light that went in. It has a longer wavelength, which basically means it's a different color. And that very specific change, that is the unique signature, the secret code that our machine is built to find.
So, it's one thing to know that this glowing thing happens, but how do we actually capture it and measure it? Well, that brings us to the instrument itself, the perfect tool for this job.
And here it is. This is the Electronics India Model 681 Digital Photo Fluorometer. This little powerhouse is really the hero of our story. It's a super precise instrument designed to do one thing incredibly well: detect that faint glow and turn it into a number we can actually use.
Now, this machine has a really clever design trick up its sleeve, and it all comes down to one specific angle. It's called the 90-degree advantage, and honestly, it's the key to why it's so unbelievably accurate.
So, why 90 degrees? It's such a simple but brilliant idea. Imagine you're trying to hear someone whisper, but you're standing right next to a giant blaring speaker. It's impossible, right? In our case, the light source hitting the sample, that's the loudspeaker. The faint little glow coming from the sample, that's the whisper. By putting the detector at a 90-degree angle, you're basically just turning your head away from the speaker. You step out of the direct blast of noise. This lets the detector hear that whisper of fluorescence with perfect clarity. It's this one simple geometric choice that kills the background noise and gives you a pure, clean signal. It's absolutely fundamental to getting this kind of sensitivity.
Okay, so that clever design is the how, but what about the how much? Let's dig into the actual specs to see just how ridiculously good this instrument is at its job.
This number, it's just staggering. The Model 681 can get a full-scale reading with a concentration of just 1 part per million of quinine sulfate. So what does that mean? It's like finding a single drop of tonic water mixed into a 13-gallon drum of plain water and getting a clear, strong signal from it. That's the level of sensitivity we're talking about here. It's wild.
And get this, it doesn't even need a lot of stuff to work with. You only need about 4 milliliters for a sample. That's less than a teaspoon. This is so important when you're working with materials that are maybe really precious or you just don't have a lot of, like in a clinical setting. It's not just powerful, it's also incredibly efficient.
So how does the machine know exactly which glow to look for? Well, it uses this awesome filter system that works like a lock that needs 2 different keys. The primary filter, that's the first key, it only lets one very specific wavelength of light get through to zap the sample. Then the secondary filter, that's the second key, sits in front of the detector,
and it will only let the very specific wavelength of the glowing light pass through. This is so crucial. It makes sure the detector isn't getting fooled by any random stray light, so you know for sure that you are only measuring the exact fluorescent signal you care about.
All right, this is all fascinating science for sure. But so what? Why does this actually matter to any of us? Let's take a look at how this technology actually steps out of the lab and makes a real impact on our world.
The places this gets used are everywhere. Seriously. Think about medicine. It's used to measure critical things like vitamins B1 and B2, or even steroids in a sample with incredible precision. Or in the pharmaceutical world, it's a huge part of quality control, making sure a drug has the exact concentration it's supposed to. And maybe most importantly, in environmental science, it's like a sentry standing guard and looking for tiny, microscopic traces of pollutants in our water.
And let's just zoom in on that environmental part for a second, because it's so important. With tech like this, scientists can spot dangerous pollutants in our water supply that would otherwise be totally invisible. They can even use harmless fluorescent dyes to trace exactly where a contamination leak is coming from and where it's going. It's an absolutely vital tool for protecting the planet.